In this video, we will deal with a couple of examples where we'll calculate the image of some elements under a given function. We begin with a simple linear function. g of x is equal to 3x plus 4. We are to find the image of 5 and 6 under the function. And in the second part, we are to determine the possible element in the domain which gives the image 17 under the function. You may pause this video for a while if you wish to think of this before proceeding to listen to the solution. The solution to the first problem. We would like to find the image of 5, or g of 5. So we calculate as thus. G of 5 is equal to 3 times 5 plus 4 equals 19. Now we could also think in terms of the substitution method. Let's do so for the image of 6. We first write out the function again and then substitute all x terms with the element 6, which gives us 22. For the second part, we first write out the function and then we substitute the image with the number 17. This is because we want to find the object which maps to 17. This then becomes a problem in simple algebra. 17 minus 4 is 3x, 13 equals to 3x, and finally we have x equals to 13 over 3. Let's have a look at the function graph. We can see in fact the solutions graphically. The image of 5 being 19, the image of 6 being 22, and as for the solution of part 2, we see how the image of 17 has its object being some number between 4 and 5, calculated as 13 over 3. By the way, notice that all the image of the elements in the domain, namely the set of all images of the function, includes all real numbers, namely the codomain itself. We shall observe something quite different in the next example. So let's look at example number 2. Here we are dealing with a quadratic function. By quadratic, we mean the highest power for x is 2. So, what is the image of 3 and negative 3 under this function? Let's look at the solution. We start by writing out the function. Then, we substitute all x terms with 3. This is equal to 10. Doing the same for negative 3, we have its image as 10 as well. Notice that the elements 3 and negative 3 both map to the same image, 10. This type of function is called a many-to-one function. Note further that even when you have a negative number as the object, the square is a positive number. And added by 1, the image remains positive, in fact, greater than 1. Looking at the graph, we see that there is no image below 1. The set of all image is called a range. It is the subset of the codomain. Looking at this function again, we see that while its codomain is the set of all real numbers, its range is in fact all numbers no less than 1. This is different from the function of the first example, where the codomain is in fact the same as its range. Now, you may well wonder why we do not just define the codomain as the range. i.e., rather than define the codomain in example 2 as all real numbers, We could have just defined the codomain as all numbers no less than 1. However, the fact is, in most cases, the range is not obvious. It is easier to define a function with the largest reasonable codomain, and that may include elements which are non-images. We shall next be looking into composite functions. I would encourage you to try viewing some of the tutorials before proceeding to the next topic.